Alrighty, y'all. Let's get cruising. So this is just kind of like matching style. Not necessarily doing any work on here, just kind of matching which of these could have these categories, titles, whatever we're calling it. Is somebody at the door? So, and you can bounce around on these. I think, honestly, that first one is the trickiest to spot sometimes. But let's see what we can do. So which one of these graphs, A, B, C, or D, might be a third degree polynomial? Definitely with you on one of those. Which one might it be, A or C? C. Why would it probably not be A? Because it's a straight line. Lines are usually just going to be an X. Like, the likelihood of a third degree being shown as an actual line is incredibly low. There's going to be some sort of curve to it. So an odd degree, I'm with you on the opposite arrows. That's probably how we got A and C. 100% with you on that. A and C are both odd. But the only one that has kind of wiggly squiggliness is going to be C. So which ones of these are going to have negative leading coefficients? There's
B and C.
More than one answer, and it's going to be B and C. How do we know that their leading coefficient is negative?
Because the
Right arrow points down. B and C.
Teachers and students, pardon this interruption. Today is day 2 of we did testing. Students received an email informing them that they were testing today. Please excuse them and let them head to their testing room. Thank you.
Okay. So how about which ones have domain and range? So both domain and range of all real numbers, or negative infinity to positive infinity. Which ones have all real numbers, which is also known as negative infinity to positive infinity? So domain and range that look like that.
A and C.
A and C. This is where we're going to have both A and C. Because it goes all real numbers for the domain, left and right. All of them have a domain of all real numbers. It's that range that really tells us. It goes from negative infinity to positive infinity. All the way up, all the way down. Which graphs have this end behavior? As x approaches infinity, f of x, or y, approaches infinity.
D.
Because this is talking about our right arrow. This piece says up. So the right arrows that go up be those two, A and D. And then our last piece on here, I just realized I used blue for the same question, or for two different questions. Sorry. Oh, and of course they were naturally quite opposite of each other. Fun times. Which ones of these have no real zeros? B, just B. Remember, our zeros, our roots, our solutions, our x-intercepts. So A has one x-intercept. B never crosses our x-axis. That's not the laser pointer. B never crosses our x-axis. C has 1, 2, 3 x-intercepts. That gives us another clue that this one's possibly degree 3. Gives us a clue there. This one has 2 x-intercepts. So the only one that didn't have any was B. Okay? Questions on any of these pieces? Okay. So I've got the skills checks graded, but they're not put into the grade book yet. So I will get them back to you tomorrow. Just because got a lot done at the meeting, but I didn't get things total done. So I'll get those done today, dear Marquette. I'll get them back to you tomorrow. Just so we can keep eyes on what's going on. So we are going to move on in what we did. So we are going to be taking notes. We are going to be identifying things and checking to see, is it a polynomial or is it something else? And then we're going to work with some operations today a little bit. So we're going to do some notes. There's a lot of things up here. You're not necessarily going to need to write them all down. I would recommend getting the definition of a monomial. And then these ones at the bottom are going to be, we're going to say yes versus no. Is it a monomial or is it not a monomial? We're going to use this to help us decide whether things are polynomials. So monomial, we think monotheistic, mononucleosis, monotone, monochromatic, other things. So like one color, one note, one syllable. One thing.
One of the vocab words in Unit 9, the section is mono.
Mono is one. So this is one variable. It can also have a number. These things can be multiplied. It can be a number, a variable, or a combination thereof that are multiplied together. So we can have numbers, we can have letters, we can have numbers times letters. Things we cannot have are roots of letters. We cannot divide by letters. So we're going to look at these examples down here and decide, is it a monomial or is it not a monomial, and how do we know what things make it wrong if it's not one? So it needs to be a number or a letter or things that are multiplied together. And there's a couple that get a little funky on that one. So how about 3? Is this going to be a monomial? Yes. I can have just a number, totally fine. So yes, this one works. I will probably just do like a green check mark from here. How about x to the 4th? Yes, because that's x times x times x times x. They're multiplied together. Totally cool. What about square root of x? No variables inside radicals. The reason for that is because if we think back to when we were looking at square roots and we would have like square root of -4 and we'd get I on stuff, that's not a part of polynomials at all. So we cannot do square roots of letters. Square roots of numbers are fine. It just gives us super icky, gross decimally numbers. But square roots of letters, that's when we wind up with I's. So no variables inside square roots. So that one does not work. How about 3 divided by x? Also no. Because we cannot divide by letters, because that's when we wind up with things that are undefined, because we can't divide by like 0. We get undefined on that stuff. So if we have anything in there that could break a rule of like an all real number situation, that's why that doesn't work. So this has x in the denominator, which I'm just going to say denom. It's not demon, denom. How about 12x to the 9th? That one's good. Totally fine. How about this next one? R to the 7th over 3. That's totally fine. Dividing by 3 is never going to give me a problem in my domain. It's never going to give me a undefined situation. So we can think of that as being 1/3 times r to the 7th. That's a valid way of thinking of it, because then it's things that are multiplied together. So we can have fraction numbers, we just can't have letters in there. This one's kind of a tricksy one. How about x to the minus 7? Why? Why is my question now.
Because it's a negative.
What does a negative exponent do? It's in Algebra 1 school. Pulling back up.
Brain.
That's what makes it flip. So this, if I write it without the negative exponent, would be y over x to the 7th. This negative exponent makes it a fraction. So now I'm dividing by x, so that's bad. Why else is this not going to be a monomial that we're working with here? 2 different letters. So 2 reasons that this is not a monomial. And then our last one here, x square root of 3. Totally fine. We can have square roots of numbers. It's an icky gross decimal, but it's a thing. We can do that. Okay? So kind of seeing the pieces on what is and is not a monomial. Awesome stuff. Because we're going to use our monomials to help us build polynomials. So monomial is one thing. Polynomial is many things. So polynomials can be monomials. They could be binomials, which would be 2, like bicycle has 2 wheels. Binomial has 2 nomials. Those guys. Trinomials would have 3. Polynomials is any number of them. So polynomial is the vaguest title. We're for the most part just going to call them polynomials. We're not going to do tons of the different things.
Umbrella.
It's the umbrella term, yes. Kind of like all thumbs are fingers, but not all fingers are thumbs. All of these are polynomials, but not all of them are trinomials or binomials. It is the vaguest sense of the word. Did I break your brain on that one?
Yes.
Uh-huh. I love that sentence. It's a fun sentence to say. All right. So a polynomial is the sum or difference, so we can add or subtract monomials together. So each of the things being added or subtracted together has to be a monomial for it to be a polynomial. So what we're going to do is we're going to say basically, is this a monomial? Is this a monomial? Is this a monomial? So that we can see, is this whole thing a polynomial? So is x to the 6th a monomial? Yeah. How about 8x to the 4th? Totally cool. How about 3? Yeah. So this one is a polynomial. Each of the pieces is a monomial, so this is a polynomial. What about this one? Is 7x a monomial? Is square root of x a monomial?
No.
No. And we already saw in the last one that 3 is a monomial. But if any one of them is not monomial, this whole thing is not a polynomial. Not a polynomial. This guy kicks us out of the polynomial club. It just takes one person to break the rules to get us kicked out. How about this one? Ooh, that's the wrong pen. Maybe one. There we go. What do we think? Is this a polynomial? What do you think?
Yeah.
There's 2 different variables. So this guy's a monomial. This guy's a monomial. This guy, 2 different variables. So this is our one that gets us kicked out of the club. We're only doing polynomials in one variable. This has too many variables. If it's got more than one letter in it, different letter, then it's not going to count. And how about this one? Is this a polynomial?
No.
Why?
Because negative.
The negative exponent, because remember that makes it have an x in the denominator, and that gives us problems because we're going to have something undefined. So this is our guy that causes problems because of that negative exponent. Okay, so identifying what is and is not a polynomial is the first part of today. Questions on that bit? Okay, because the other part of today is going to look a little bit more complicated, but I promise it's really not. It's just got the first part has a lot already. Not a lot. But I'm going to give us two polynomials. They will be polynomials. We don't even have to check. And I'm going to ask us to add them together. So the two polynomials together. So here we have, I'm going to show you, I promise. We have f of x. So here's our first polynomial, and it is a polynomial, 6x cubed, 7x squared, minus 2x plus 5. That's our first piece. And we're going to add to it my g of x, which is x cubed, minus 4x squared, minus 8x plus 1. So we're adding these pieces together. That's what it says up here to do. So what we're going to do is we're going to take our f of x, this guy, and we want to add it to our g of x, this guy. I'll give you guys a second to write that down because I know there's a lot of pieces up there. Okay. So what we can do here is we can think of this kind of like when we would do our substitution stuff. I know what f of x is. I'm going to put it in place of f of x. So we're going to take our 6x cubed plus 7x squared minus 2x plus 5 plus x cubed minus 4x squared minus 8x plus 1. We're going to add the two suckers together. With the adding, we don't need to. If we were subtracting, we would need to because we would have a step that we would need to do before we can just combine like terms. So 6x cubed plus 7x squared minus 2x plus 5 plus our g of x, which is that x cubed minus 4x squared minus 8x plus 1. So I'm taking these two pieces and we're going to smash them together to add. So what we're doing from here is combining like terms. So what like terms do we have in here that we can combine?
X cubed, x
Mhm.
squared, x.
So we have our x cubed that's going to combine with 6x cubed. So it's going to give us 7x cubed. 6 things plus 1 thing gives me 7 things. I'm going to have my 7x squared that combines with minus 4x squared, giving us how many x squareds? Positive 3x squared. Our x's? Minus 10x. That's I owe you $2 and I owe you $8, so combined I owe you $10. When in doubt with negative numbers, think about it as money. We are usually significantly better at keeping track of that. And then our numbers. So I've got a 5 and a 1.
6.
Ta-da! We did it. This is our answer. We're getting a highlighter. There we go.
We don't find x on this.
We don't have an equal sign. We can't actually find x. I'm just going to say, wait till Friday before you say this is too much.
I'm scared now.
Don't be. We'll get there. I promise. All right, so we've taken these two equations and we've added them together. I wonder what else we're going to do with them. Because if we add something, we can also then subtract them. We're going to do the same thing. It's almost identical. So adding is just combining like terms. We're going to put them next to each other, combine like terms. There was only one additional step when we look at subtracting. We're going to use these same equations and subtract them. I'm just going to change the page so that we look at it, but it's the same equations. I wasn't going to make you write that many different equations. So it's the same dudes, but now we're subtracting them. So I'm still going to use my f of x being purple and my g of x being green. So we want to do f of x, and we want to subtract everything that's in g of x. I'm subtracting the whole thing. So in this case, since we're subtracting g of x, we need at the very least for g of x to be in parentheses. If you want to put both in, totally fine, but g of x needs to be. So my f of x is still just going to hang around. So my 6x cubed plus 7x squared minus 2x plus 5. And we need to subtract everything that's in g of x, all of it. X cubed minus 4x squared minus 8x plus 1.
So we basically distribute the negative.
100%. That's what we're going to do. We need to distribute the minus sign. Because I need to subtract the x cubed, I'm going to subtract minus 4x squared. I'm going to subtract minus 8x, and I'm going to subtract 1. So it's going to play games with our signs, so we need to be super careful. Because this is going to give us, the purple pieces are just going to drop down. Our 6x cubed plus 7x squared minus 2x. My screen just blinked, and I don't know why, but that's okay. And then what we're going to have is we're going to have minus x cubed. If I take this minus sign to our minus 4x, what sign is it going to have? Minus, minus, a plus. Plus 4x squared. Minus negative 8 becomes plus 8x. Minus 1, minus 1. So when we subtract, we need to distribute the minus sign through. That's the only difference between adding and subtracting. So from here, it's the exact same. Combine our like terms. So I'm going to take my cubes, my 6x cubed, but this time we're minus x cubed. And that's going to give us 5x cubed. I have 6 things here, taking away 1. Then let's look at our squareds. I have 7x squared and 4x squared.
11x squared.
Positive 11x squared. Minus 2x and 8x. Yep. Plus 6x.
Plus 4.
And then our 5. Oop, I've already used green. Now use green. Need another color?
You used red twice.
To be fair, on mine it's red and orange. They're significantly more different on mine than on yours sometimes. Ooh, weird, but okay, we'll take it. Gold. 5 and minus 1 gives us a plus 4. But I was gonna say, try and keep them different colors. Sometimes they show up better on my iPad than on the screen.
I love that.
It's so much fun. We love technology. It's the bestest.
It's like taking a picture and it doesn't register that it's that it's one color, and it comes out in a picture in another color. I was trying to take a picture of this purple Jeep like a couple years ago, and it came out blue. Wait, no, it was teal.
That happens. Okay, so questions on this first set of adding and subtracting. We're going to do another set, and then I'll finish off the homework. So I'm going to give us another set of functions, another f of x and a g of x. We'll add them, we'll subtract them, and then we'll be done. Okay? So here's our new f of x and our new g of x. We're going to add them, and then I'll go to the next page and we'll subtract them, because that lets me not have to put everything together. So we've got our f of x, that is 2x to the 5th plus 11x to the 4th plus 7x minus 8. And our g of x, which is 5x to the 4th minus 9x cubed minus 3x plus 4. And we're going to add them together. So we want to take our f of x and add g of x. That's what the instructions tells us to do, is to add them together. So we're going to take all the pieces in our f of x, our 2x to the 5th plus 11x to the 4th plus 7x minus 8. And we're adding those to our g of x, 5x to the 4th minus 9x cubed minus 3x plus 4. If it helps for you to put them in parentheses on this part for the substitution in, that's totally fine. The parentheses aren't doing anything, but it doesn't hurt. And then we're at our combine like terms situation. So what are we going to do to try and combine these together?
Combine all like terms.
So starting with my biggest piece, I've got an x to the 5th. Do I have anything that's going to combine with it?
No.
It's the only one. So we have 2x to the 5th. How about our next piece down? We have x to the 4th. 11x to the 4th.
Yeah.
5x to the 4th. So we're going to have
6x. 16x.
There we go. It's okay. It's early. We're still waking up. Brain's booting up.
The ADHD medicine hasn't kicked in yet, you know?
Preach. All right. What piece are we going to do next? Yeah. 9x cubed, or 9x to the 3rd. 9x3 works. I caught what you're throwing down. And I don't have another x cubed, so I'm going to put that piece next. So minus 9x cubed. Sometimes we just won't have things to combine. We're just putting them in order. We're putting these into our standard form where they're going from biggest to smallest exponents. That's how we're deciding which piece is going next. How about next? What's going to go next?
7x.
Our 7x combined with our minus 3x. Positive 4x.
Negative 8 plus 4 is negative 4.
Yep, our negative 8 plus 4 gives us negative 4. It is for everything except purple. That's how I decide. Makes it less chaotic when I'm trying to pick a color. It's too many choices. Then I can make it narrows down my choices. I'm like, pick a shade of red, pick a shade of orange that's visually different. Okay, we're going to do the same functions again, because again, I'm trying to not make you write a gazillion polynomials over and over and over again for no reason. And we're going to take those same functions and we're going to subtract them. So same vibe. It's the same f of x, the same g of x. We're going to just subtract them now. So my f of x I'm doing in purple, my g of x I'm doing in my green. And we want to take our f of x and we're going to subtract g of x. So when we put this in and when we substitute our pieces in, whichever thing we're subtracting needs to be in parentheses because we're going to have to distribute that minus sign. So when I put these pieces together and we have our 2x to the 5th plus 11x to the 4th plus 7x minus 8. I mean, I wasn't kidding with the whole, there's lots of writing. It's not super complicated, but there's just lots of writing involved. And our g of x, which is 5x to the 4th minus 9x cubed minus 3x plus 4. And then we need to distribute that minus sign through. So our f of x, our purple stuff, isn't going to change at all. We're going to have our 2x to the 5th, 7x to the 4th, plus 7x minus 8. My wrist is going to hurt by the end of the day. It's because I get to do this 4 more times, or 3 more times. And so we need to distribute this minus sign through. So we're going to subtract our 5x to the 4th. We're going to subtract negative 9x cubed. So minus minus becomes a plus. Minus minus becomes a plus 3x. Minus positive 4 becomes minus 4. So we need to make sure we distribute the minus sign because we are subtracting everything that's in g of x, not just the first piece. It is super important. The most common mistake that happens is we just forget the parentheses and we're just subtracting our 5x to the fourth and everything else doesn't change signs. That's the most common mistake we have. So after this, it's our combining like terms and then I'll stop talking at you. Yay, we love that. All right, so our biggest piece is going to be which piece? What's going to go first?
2x5.
Yes, our 2x to the 5th. What's going to come next?
11x4 minus 5x.
Yes, 11x to the 4th minus 5x to the 4th, which is going to leave us with what?
6x.
Positive 6x to the 4th. Then what are we going to have? What's going to be next?
Plus 9x.
Plus 9x cubed. We don't have any squared pieces. So our next piece is going to be these x's. I've got our 7x and our 3x, which is going to give us what? Yes, 10x. Last one.
Negative.
So we have our minus 8, minus 4, which gives us minus 12. Okay? So I told you, they look kind of scary, but I promise they're really actually not super bad. Okay, so I'm going to get our next homework, because we didn't have homework yesterday, so I'm nice, but I'm not that nice. We got homework 4-3. Today is Wednesday. We're going to talk more about what's on here tomorrow, but you can do everything on the front and the review on the back. So what we're going to do tomorrow, today we did adding and subtracting. So tomorrow we're going to add in multiplying polynomials together. So we're going to keep working with polynomials, this whole chapter and even next chapter is about polynomials. But we're going to work with these more tomorrow, and tomorrow we'll add in the multiplying that's on the back of the paper. Okay? So you've done multiplying like it before, so some of these you might be able to figure out because we've done these before. But we'll talk through it more specifically tomorrow. So you guys have 10 minutes to the end of the period and 6 minutes until announcements start. So if you want to work on stuff, ask questions, all that jazz. Now's a great time to do so. Look at us getting time to actually work and ask questions. Oh my gosh, we love it.